in the information, plugging in the x values, we got y values. So how about we plot those points on our graph? Okay, let's go ahead and plot those points on our graph. So P of 10 was equal to 4. So that means we have the point positive 10, positive 4. So if you draw yourself a little axis there somewhere on your graph paper, we may have a couple more examples to fit on there, so you may not want to use the entire thing, but I have more if you need it. Okay, I have more graph paper if you need it. Don't freak out. So positive 10, positive 4 was a point. Negative 10, negative 20, well, that's not going to fit on my graph. It might fit on yours, but it's not going to fit on mine, so I'm just going to leave that one off. 0, 5, that was a point. 1, 2, 3, 4, 5, so I'm going to plot that on there. 2.48 and 0.24, you know, usually we plot whole numbers, but that's not the only thing we can plot. We can plot decimals. Yeah, estimated about right there. Nope, that would be 1.5, not 2.5. There we go. Okay, about right there. Now, those are the only points that I was given. Now, I could plug in as many numbers as I wanted to. Those were just the ones that we were asked to plug in. So now I'm going to rely upon my just basic graphing skills, of which some of y'all might be struggling, but that's okay. We're going to work with it. Okay. So the first piece, x is less than 0. Remember I said less than means left. So to the left of x equals 0, I'm going to do this on my graph. I'm going to put a little line right here and remind myself this is 0. So to the left of that line, the y-axis, my graph looks like the function 2x. Now, you know, well, how am I supposed to put that on my graph? Here's what I do. Even though that does not have the equal to, it just says x is less than 0. It doesn't have the equal to. I'm still going to plug 0 into that function. So 2 times 0 is 0. Since it did not have the equal to, that means I'm going to put an open circle at 0, 0. Okay, I'm going to put an open circle at 0, 0. Now, some people at this point like to use the slope to graph the rest of the line. Once you have one point, then you can start counting your slope. Or you can plug in another point to the left of 0. Give me a number to the left of 0. What's a number to the left of 0? Negative 2. All right, plug in negative 2. 2 times negative 2 is negative 4. So negative 2, negative 4 gives me another point. When I have 2 points, I can draw a line, right? I just draw the line and connect those 2 points and continue it. It has a slope of 2. Continue that with a slope of 2. But I don't go past x equals 0 because this only applies to the left of 0. Now, let's look at that middle piece. It says when x equals 0, the y value is x plus 5. So 0 plus 5 is 5. That is just that random point right there. At 0, 5, that is all that middle piece tells us to do. When x equals 0, here's your y value. That's it. Nowhere else, just when x equals 0. So let's look at the last piece. When x is greater than 0, greater ends in an R to the right of 0. So now I'm looking at the right side. Now I already have 2 points over here. Technically, I could just draw my line through that. But I got to come all the way over here to 0. So I'm going to plug 0 into that piece as well. 0.5 times 0, 0, minus 1. So that's negative 1. So I have an open circle at 0, negative 1, because it didn't have an equal to. It was just greater than. It doesn't have an equal to, so I put an open circle right there. And then I have those other 2 points. So I'm just going to draw my line through those other 2 points that I already have there. Now, if I didn't have those 2 points, then I would just plug in some numbers. Plug in 1, plug in 2, plug in 8, plug in something to the right of 0, and then connect your open circle, your starting point, to that other point that you've produced. Okay? Notice, this is a piecewise function. What test does something have to pass in order to be a function? What test do we call that? The vertical line test. Okay, the vertical line test. So take a vertical line. Go across your graph. Make sure you only touch the graph at one point at all times. Now, you might say, well, isn't that a problem right there? Well, that's not a point. That's an open circle. That's not a point. That's an open circle. Here's my point. I'm only touching one point in the graph at x equals 0. So it's not a problem. Okay? Make sure that your lines don't end up overlapping and crisscrossing. Okay? Some people, that's their struggle. Their lines start crossing over, and it's not a function. You got to know where to change it, where one graph ends and the next graph begins. All right, we'll do a few more of those to help us out. Now, this would have helped us with this question up here. What input value will give an output of -6? So where is our y value equals -6? Well, we can easily, looking at the graph, go to y equals -6 and see, okay, well that happens where x equals -3. All right, so that could have helped us with that question instead of doing it algebraically. All right, questions so far? Okay, let's look at a few more examples. Example 2 asks us to complete the table for the following piecewise function. Our function is equal to 2x plus 1 when x is less than 2, and x squared minus 2 when x is greater than or equal to 2. All right, so it wants us to start with -3. Well, is -3 less than 2 or greater than 2? Less than. So that means we plug it into the first piece. 2 times -3 is -6. -6 plus 1 is -5. All of these values, let's look at the table really quickly. All of these values until we get to 2, or actually I put that line on the wrong side. Until we get to 2, because 2 goes into the second piece. So all these values here follow 2x plus 1. So really, if you wanted to, you could put 2x plus 1 into your y equals, and you could look at the table. Or you could practice some mental math and do it by hand. So x equals -2, plug that in. -4 plus 1, that's -3. For -1, that goes in the first piece, so -2 plus 1 is -1. Plug in 0, we get 1. Plug in 1, we get 3. Plug in 1.5. Your table won't tell you that unless you go in and change some stuff, so you got to be able to know how to do it by hand. 2 times 1.5 is 3. 3 plus 1 is 4. When we get to x equals 2, that goes into the second piece, because the second piece is the one that has the equal to. So 2 squared minus 2 ends up giving us 2. The square root of 5. Now, let's think about this for a second. If you square a square root, what happens? It cancels, right? Squaring a square root, you just get that number. The square root of 5 squared is just 5. 5 minus 2 is 3. Now, if you don't feel very confident in that answer, of course you can plug it in. Just make sure that you put the square root of 5 in parentheses. Or at least that you close your parentheses after the 5. I think that'll be okay as well. Okay. If you would get lucky in this case if you didn't close your parentheses, it would still give you the correct answer. But parentheses are important. Okay, and then plugging in 3. 3 is greater than 2, so 3 squared minus 2 is 7. All right, so that's just more practice on evaluating, deciding which piece it falls into. Tell me this, which piece of the function is not linear? The first piece or the second piece? The second one. The second piece is quadratic. So you would write x is greater than or equal to 2 for the answer to that question, because that identifies what part of the function. Okay? For x is greater than or equal to 2. Questions? All right, let's look at a little bit of a word problem. Okay, example number 3. I know y'all hate word problems, but here's the reality. The world is full of piecewise functions. This is actually something that's very real world. When y'all love to ask, well, when am I ever going to use this? Well, here's an example of how. Braylon wants to join the gym. If he joins for 7 months or less, it will cost him an initiation fee of $40 plus $12 per month, including the first month. So $40 flat fee and then $12 per month. If he joins for more than 7 months, it will cost him $130 for the whole year. If x equals months, complete the table to show how much Braylon can expect to pay depending on the number of months he plans to work out. So let's think about this. If he's just planning to work out for 1 month, how much is it going to cost him? $52. He's got to pay the flat fee plus the monthly fee. So it's going to cost him $52 for that first month. Okay, if he does 2 months, then you got the flat fee, your monthly fee twice. So add $12 to that. So 64, 76, 88. Y'all tell me if I screw something up. 100. 112. Okay, so for 7 months or less, so this one includes the 7th month, he's got to pay that monthly fee. So that would be what, 124. Okay, if he joins for more than 7 months, so 8 months or more, it will just cost him $130 for the whole year. So from this point on, our table is just going to be 130. It doesn't matter whether he works out for 8 months or 12 months, he just has to pay that $130 fee. So there's the table. Let's write a piecewise equation for this function. Now the easy part is the second part. It's $130 when x is what? Greater than 7, right? As long as the number of months x is greater than 7, it's just $130. The first piece costs $40 plus 12x. 12 times x. X is the number of months. So that's when x is less than or equal to 7. And if that really bothers you, the fact that the x comes last, if you want to write that as 12x plus 40, have at it. Okay, it's the same thing. I'm not going to count off for that. All right, questions? Okay, flip your paper over. We're going to skip example 4 because that's really where we started with this. Example number 4 goes through the absolute value function and the fact that negative x is the left side, positive x is the right side. I got this from another teacher, so kind of did the reverse order there, but that's why we're skipping example 4. Let's look at example 5. Timmy's t-shirt place has different prices depending on how many t-shirts you order, and this happens all the time. The more t-shirts you order, typically the cheaper it costs per shirt. So they give us the piecewise function. How much will an order of 25 t-shirts cost? So if we want 25 shirts, which piece of the equation are we going to use here? The first, second, or third? The second. Okay, and we're simply just going to plug in 25. 8 times 25 plus 3, $203. Okay, how about if we want 125 t-shirts, which piece are we using? third. 7 times 125 plus 3, $878. Okay, what is the price per shirt for an order of 10 shirts? So not asking how much it's going to cost for the entire order, but what is the price per shirt for an order of 10 shirts? $9. 10 shirts fits in the first piece. 10 is between 0 and 20, and it's 9.00 times X, so that must be the cost per shirt, $9 per shirt. Okay, if the bill was $171, how many t-shirts were ordered? And apparently there are two possible answers. So how would we approach this? If we know that the bill's $171, we got to figure out how many t-shirts. What do we need to do? Okay. Use the last function and what? Set it equal. Okay, set it equal to 171. So let's try that out. Let's do 7x plus 3 is equal to 171. So we're going to subtract 3 and divide by 7. Let's see what we get. 171 minus 3. Oops, I only have 17 minus 3. 171 minus 3 divided by 7. X is 24. Does that fit in our domain there? No. 24 is not greater than or equal to 40, so that's not going to work out for us, okay? It must not have been the last piece. So let's check the middle piece. 8x plus 3, I'm just going to mark it out. Okay, 8x plus 3 equals 171. Same process, subtract 3, divide by 8. So 168 divided by 8 is 21. Okay, does 21 fit on our range there? Yes, 21 is between 20 and 40. So we could have ordered 21 shirts. So apparently, let's check the first piece. Let's see if it works as well. Okay, 171 divided by 9. X equals 19 shirts. 19 fits between 0 and 20. Okay, so this could have been an order of 19 t-shirts costing $9 a piece to give us a total of 171. Or it could have been an order of 21 t-shirts, but they only cost $8 a piece, but apparently we have this flat fee of 3 for some reason. Okay, so it is possible for these piecewise functions to give multiple answers. Sometimes, depends on the conditions. All right, any